Good evening, everyone. I hope all of you are doing great. So, welcome to the week 6 of Fuzzy Sets Logic and Systems and Applications problem solving session. I am your teaching assistant. My name is Saradhi Pravalika. I'm a PhD scholar and a Prime Minister Research Fellow from the Indian Institute of Science. And let's just go back to our weekly instructions. So please be aware that this session is being recorded and the recording will be put on YouTube and the YouTube links will be provided on the NPTEL portal. Right. So be respectful during the session to your peers and towards me as well. So please put all your questions in the chat box during the session. And in these sessions, I'll be discussing mostly uh, assignment relevant questions and a little bit of theory, not too deep into the theory. And wherever required, I'll also help you with MATLAB and coding. And after 12 weeks, that is a given weeks, I'll also be available for one additional class in case if you wish me to um, discuss any existing topics or relevant to the course. Okay. So, okay, those are the common instructions that we usually give every week. And apart from that, in case if you want to know anything which is not exactly covered in the syllabus and you kind of like want to go off track and want to ask questions, let me be honest, this is not my area of research, but I was very much interested in fuzzy sets. So that was the reason I have taken up the problem solving sessions. Like whatever I'm teaching you, I know all of that. But when you are asking more of a complex side, even I'm not sure, and I most certainly do not want to give you any wrong answers. Okay. So what I would suggest to you is that kindly put your questions in the Google group. Okay, the TA who is along with professor, he will consult the professor and he will uh, answer back to you. Okay, I do not have any direct contact with the professor. So because since I don't have any direct contact with the professor, I cannot give you a right answer. Okay, and I most certainly do not want to like give you a wrong answer. So that is the reason I'm suggesting you to, in case if you're going off the syllabus, kindly ask your questions in the Google group rather than in the session. Okay, this is what based on last week's class. Okay, that is what I was telling you. Okay, with that, let us just go back and have a quick summary of what we have dealt with in the last class, right? So, yes. So in the last class, we have seen arithmetic operations in fuzzy numbers. So the class before that, we have seen addition. So in the last class, we have seen subtraction, and we have done some examples, and then we have seen multiplication, right? And then we have gone to division, and then we have done complements. And in complements, we have seen Sugeno's class of complement and Jaeger's class of complement, right? So once those are done, we have also seen T norms are also called as S conorms. So I hope you all remember, and we have seen the most common types of T norms and how do we use them, and we have seen some examples in each of the each T norm operators, right? And similarly, we have also seen S norm or T conorm. So T norm is basic. We had basically taken the intersection, whereas in S norm we have taken the union, right? Just, sorry. So in S norm we have taken the union, whereas for T norm we have taken the intersection, right? Why I'm repeating this again is because today we are going to see the T norm and S norm operators. Okay, then we have seen different axioms for S norm and T norm as well, and then we have done some examples, right? And then we have seen the last year assignment questions and all. So in today's class, we'll be discussing parameterized T norm operators and also parameterized S norm operators. Once those are done, we'll be looking at the fuzzy relations. Okay. Um, okay. So when we say parameterized t-norm operators, so we all know what t-norm operators are, right? So here in parameterized t-norm operators, we have three types. Okay. Dombey's class of t-norm and Prade class and Jaeger's class of t-norm operators, right? So let us first see Dombey's class. So Dombey has one extra parameter, that is lambda. Lambda is a parameter that we take, and the inputs are the membership functions of new A and new B. Sorry, new A and new B membership functions from A and B for given value of X, right? Uh, and it is 1 over 1 plus uh, 1 by nu A minus 1 whole power lambda plus 1 by nu B of X minus 1 whole power lambda and whole of 1 by lambda. Okay, and this lambda, it falls in between 0 to infinity. And a small uh, note I have to tell you. When we use these brackets, so when we use a curly bracket, sorry, this normal curve bracket, it means that when I say A and B are not included in a given range. So when I use this brackets, all the values that fall in A and B will be included, but not A and B. When I use square brackets, then uh, the values A and B are also included. So here, when I say lambda belongs to 0, comma infinity and curly and curve brackets, it means that it does not include 0. Okay, it does not include 0. Rather, it will take every other number that falls in between 0 to infinity. And wherever infinity is there, we always use a curved bracket rather than a square bracket. Okay, so this is something that most of you all know, but just in case, last week we had one question something. So I just felt like, okay, when I gone through the recording again, I just felt like I didn't explain it clearly, like why are we not taking 0 into consideration? So I just thought I'll just come back to it. Okay, so it's as simple as that. For Dombey's class, we have this formula. We'll be given a lambda value. We'll be given the membership values from fuzzy set A and fuzzy set B, and you should be able to calculate this T, right? Okay. So this is one example. I hope it was visible. I hope it is clearly visible. Okay. Okay. Here I'm saying TD of, it's actually lambda. Okay. Sorry. So here I'm saying lambda T lambda of A comma B. So here A is nothing but new A of X and B is nothing but new B of X. Okay. And I have given some values that saying new A of X is equal to 0.6 and new B of X is equal to 0.8 and lambda value is equal to 2. So can you guys find the value T lambda using these values for Dombey's genome? The formula is right here at the top. The function is right at the top. So can you just put these values here and tell me what is the answer? I'll wait till 6:15. Okay. Use your calculators because we are dealing with powers. So it'll get quite tricky. So I'll wait till 6:15. Just let me know once you're done. Manas, I have given some options here. Can you please check your calculations once? I have given A, B, C, D options here. Actually, you're close to the answer. Just round it off. Um, we'll wait for Yamuna as well. Okay, we'll wait for 2 more minutes and we'll try to do it. Okay. Thank you, Manas and Yamuna. So, yeah, you are right. Let me just do it once. Okay. So, first, I'll just take one part of the denominator, the bottom part here. Okay. Uh, I know that mu a is equal to 0.6. So 0.6 minus 1, that is equal to my 1 minus 0.6 by 0.6. 0.4 by 0.6, that is equal to 2 by 3, is equal to 0.6667, right? Okay, so that is one. Then for B, 1 by 0.8, 0.8 minus 1, 1 minus 0.8 by 0.8, 0.2 by zero point 0.8, that is equal to 1 by 4, that is equal to 0.25. Okay, so now I have to take lambda, right? So this is equal to 0.6667 whole square. Lambda equal to 2, right? Six, six, this is 0.444. I'm just rounding off to 9. Okay. So then I have mu b of x minus 1 power lambda. So that is equal to 0.25 whole square. That is, this is 625. I don't know the points. Okay. Okay. So we got that. And then we have to add both of them together. So let us add both of them together. This plus this, 0.4449 plus 0.0625 plus 0.0625. This is 0.5074. Okay. So then what we have to do? We have to take the square root of that. So this 0.5074 power 1 by lambda. So that is equal to 0.5074 square root of 0.5074 is equal to 0.712. Okay. So then we have to take 1 plus this value. So 1 plus 0.712 is equal to 1.712. So we have to take it to the denominator. Well, 1.712. So I'm getting 0.584. So these are all approximations because there are a lot of decimal values and I have rounded off with a different precision, and you might have done it with a different one. So then we'll just check with what all options are given to us, and then we'll choose the one which is closer. So for us, the closer one is 0.60. So the answer is 0.60. Okay. So that is how you do it when you are asked only for the T lambda. Okay. T subscript lambda. But if you are given a fuzzy set as a whole, how are you going to do it? So capital X is our universe of disclose. So it is having 1, 2, and 3. And we have two fuzzy sets in the universe of disclose, A and B. And all of them have their respective membership functions, all the X values, right? And the lambda value is given as 2. Uh, So we'll, can you all find the T lambda for each of the pairs? So for the first pair, for the first pair, you have to keep mu a of x is equal to zero point 0.2 and mu b of x is equal to zero point 0.4. And for the second pair, mu a of x equal to 0.7 and mu b of x is also equal to 0.7. And then mu a of x is equal to 0.8 and mu b of x is equal to 0.3. Can you all find the T lambda for all of these three pairs? And can you tell me what is the T lambda value for those respective ones? I'll wait for some time. So it's same as what you have done in the last question. Okay, similar to that. Please follow this. I think if we are going to calculate for all the three, it will take quite a lot of time. So I would suggest you guys like try for all of the values separately later. But for now, I will give you the multiple choice. Okay, and you have to just pick the right answer. Okay, the choice in A 1, 0.09, 2, 0.38, 3, 0.24, and 4, 0.90, 5, 0.41, B, 1, 0.15, 2, 0.42, 3, 0.20, 4, 0.88, and 5, 0.39. B, 1, 0.12, 2, 0.36, 3, 0.22, 4, 0.85, and 5, 0.40. Okay, so these are your options. So what I'll suggest is you maybe try finding for one pair, any one of the pairs, and when you get your T lambda value, that is going to be your new membership function. Okay, so then just check for the corresponding ones, which one you are getting. Okay, and then you tell me what is the right answer is. Okay, I'll just mute my mic for a minute. There is some noise outside. I'll just ask them to wake. slow it down. I'll just wait till 6:27 p.m. Okay. Please give your answers before then. So Yamuna, if you are doing the first one, that is 0.2 and 0.4, then the x value is equal to 1, right? So here, for x equal to 1, the membership value from A is 0.2. The membership value from B is 0.4. When we take these two pairs together, then the x value is going to be 1, right? So for the first one, the x value is equal to 1. For the second one, it is going to be 2. The third one, it is going to be 3. Okay, sorry, I actually took it from a different place. There, just 3. I wanted to simplify it, so I only gave 3, but in the textbook, there are 5. Okay, any answers? Shall I do the answer or? Okay, let me do it then. 1 by nu a of x minus 1 So I'm taking it for the first pair. Okay. For 1, you got 0.19. Okay. Uh, Let me just try it. Okay, 1 second. 1 by 0.2 minus 1, that is equal to 0.8 by 0.2, right? So this is equal to 4. And 1 by nu a of x, so nu b of x minus 1 is equal to 1 by 0.4 minus 1. That is equal to 0.6 by 0.4. That is equal to 3 by 2. It's equal to 0.66. Sorry, 1.5. 1.5. So then I have to take the squares, right? So it's 1 by 1 plus 4 square is 16 plus 5 square plus 2.25 square root, right? Okay, so let me find the square root. 16 plus 2.25. So this turned out to be 1 plus 4.272 plus 1 makes it 1 by 5.272. So 1 divided by 5.272, that is equal to 0.1890. Hmm. Yeah. Okay. Okay, we got a completely different answer. They also got the answer 0.188. Yeah, Yamuna, you're right. We are getting 0.189 only. Oh, Manas has done the other ones as well. Oh, great. Okay, so we'll go with Manas' answer. Even I should have done it. I shouldn't have trusted the textbook directly. Okay, so for this, the option is going to be none of the above. Okay, so sorry for trusting the book directly. Uh, yes. So thank you, Yamuna and Manas. You guys are right. Okay. So I hope you understood how do we find the T lambda, and like only when nu A and nu B are given, and when two fuzzy sets are given, how do you find it, right? So first you take down all the pairs together, right? Like for x equal to 1, x equal to 2, x equal to 3, all the pairs you take together, then you find the T lambda value, and then that T lambda is nothing but the membership value for that given value of x. Okay. So is it clear? Is this part, is this whole part clear, or is there any questions? Or can I move to the next part? Thank you, Yamuna and Manas. Okay, so we are going to the next part. So the next part is Prade's class. Du Bois Prade's class. Okay, so how we had lambda in the previous class. Here we are having another parameter called as alpha. So in the previous class, the lambda was ranging in between 0 to infinity, whereas alpha here lies in between 0 and 1, including 0 and 1. It is a square bracket, right? So 0 and 1 are also included. And then this is the equation that we use. So here is lambda, sorry, alpha, right? So for a given for two given fuzzy sets, you take the membership value from A, you take the membership value from B for both having same X values. On the numerator, you multiply both of them, and in the denominator, you take the maximum value in among new A, new B, and alpha. So whichever is the maximum value, you take that, right? So that is going to be your new membership value. Okay, fine. Uh, and also, as said, lambda values range in between 0 and 1. Would you like to try this example? So I have given two fuzzy sets and alpha value is equal to 0.1. Would you like to try? Or okay, I'll do one thing. I'll show you one pair. Okay, for x equal to 1, nu a is equal to 0.4, nu b is equal to 0.3, right? Let's take p alpha of 0.4 comma 0.3 is equal to 0.4 into 0.3 divided by max of 0.4 comma 0.3 comma 0.1, right? So this is going to give us 0.12 and divided by 0.4, right? So this is going to give us 0.3. So the new membership function value for the t norm in between A and B is 0.3. So 0.3 for x equal to 1 plus, kindly find the other values and let me know what you're getting. Okay, if both of you are getting the same values, then sure, we'll go ahead. If values are not matching, then we'll do it. Okay, I'll wait for 5 more minutes. I'll wait till 6:40. Okay. Okay, both of you got completely contrast values. So let us do one more. Okay. So T of alpha for 0.6 and 0.5. 0.6 into 0.5 divided by max of 0.6, 0.5, and 0.1. So this is equal to 0.3 divided by max is 0.6. So this is equal to 1 by 2. This is equal to 0.5. Manas, can you just check it once again? Okay. Let's do for another pair. 0.8 and 0.9. 0.8 into 0.9 divided by max of 0.8, 0.9, 0.1. So this is equal to 0.72 divided by 0.9. Right? So this is equal to 0.8. Did I make a mistake? Okay, so this is 0.5, 0. Okay. No worries, Manas. Okay. So for the rest two, I'll go with what Yamuna has got. Okay. Okay. So this is our final answer. Right? Okay. So is this class clear? Any questions in this particular class? Hmm. Great. Thank you, Manas and Yamuna. So this is the last class in T-norm operators, parameterized T-norm operators, right? So in this is the Jaeger's class. Okay, do not confuse it with Jaeger's complement. Okay, so in this we write the membership value as t to the t subscript w, right? Because w is a parameter for us. So here the W ranges in between 0 to infinity, where both are curly brackets. So it does not include 0, but every other value it includes in between 0 to infinity, right? So we take 1 minus minimum of 1 or 1 minus nu a x whole power W or omega plus 1 minus ub of x whole power W whole of 1 by omega. Okay, this whole is one part and this is 1. So whichever is minimum, we'll take those values. Okay, right. So let us try one example. Okay, so we have two fuzzy sets A and B, and the universe of disclosures is 1, 2, and 3. Right, and W or omega is equal to 2. So now we have to find the other other fuzzy set. Okay, for a given A and B fuzzy set. So let us try to do it. So T2 is equal to 1 minus minimum of, let us find 1 minus nu a of x whole power W. Let us do it for x equal to 1. Okay, 1 minus 0.3 whole square, that is 0.7 whole square, that is equal to 0.49. Okay, so 1 minus nu b of x power W, that is equal to 1 minus 0.5 whole square. 0.5 whole square equal to 0.25. Right? So now let us add 0.49 plus 0.25. 0.74. Right? Now let us take, now we'll take square root of 0.75, that is equal to 74. 0.86. Okay. So 1 minus minimum of 1, 0.86 here, right? So let us bring it over here. So T2 is equal to 1 minus 0.86. So the value is going to be 0.139, that is equal to 0.14. The option is none of the above. Okay, so this is 0.14 for x equal to 1. Okay, yes, yes, Yamuna, you are 100% right. It is 0.14. Okay, Manas, were you able to get the value? Any questions anywhere? Yes, amazing. Thank you, Manas. Thank you, Yamuna. So, so like this, you will be able to do for the other two values as well, for x equal to 2 and x equal to 3. So, with the interest of time, I now onwards, I'm going to go a bit faster. Okay, because there are a lot of things to cover and we have 1 hour 15 minutes remain. So, okay, so far we have covered parameterized T norm. Now we are going to take S norm. Okay, so whatever you have done in T norm, you are just going to do the opposite of it. So wherever you have taken lambda in DOMBs, you are going to take minus lambda. Okay, wherever you have taken minus, you are going to take plus. Right? Okay, so even for parameterized S norm, you have three classes with the same names: Dombey, Du Bois, Prada, Prada is Jaegers. Okay, so all the three classes you have. Okay, so first let us look at Dombey's. So if you compare this with the previous one, what all had changed? So the lambda has changed from plus lambda to minus lambda here, and plus 1 by lambda to minus 1 by lambda, it has changed. Right? Shall I bring that one here? Over here, right? So wherever there is a minus, it had become a plus. Wherever it is a plus, it had become a minus, right? We were here. Okay. Here. So again, the lambda values range from 0 to infinity as usual, similar to what we had seen in parameterized p-norm operators. So same goes here as well. Okay. So I'm not sure if these answers are correct. Just erase it off. Okay. Would you like to find S lambda for a given new A and new B values? 1 by 1 plus 1 by 0.3 minus 1 power lambda minus 3 plus 1 by 0.7 minus 1 minus 3. For this whole thing, I'm going to take minus 1 by 3. Okay. Uh, okay, let us do this one together. Okay. I'll take 1 by 0.3 minus 1 first. So that is equal to 0.7 by 0.3. So let us leave it as 7.3. Now, when I say 0.3 minus 1 whole power minus 3, so that is going to be 3 by 7 whole cube, right? So this is 27 and 7 is 343. Okay. So 27 divided by 343 is equal to 0.079. Okay. Now let us find the other one. 0.7 minus 1 equals to 0.3 by 0.7. Is 3 by 7. So when we take the reverse, it's going to be 7 by 3 whole cube, right? So 343 divided by 27. 343 divided by 27 equal to 12.70. Okay. So now let us add both of them. Uh, okay. Thank you, Manas. I'll just see. Even I'm not sure of the answer. So, okay. Let us do it. So when we add both of them, 0.09 plus 12.70 plus 0.79. So this is equal to 12.783, right? Now we have to find power minus 1 by 3. So 12.783 whole power 1 by 3 is equal to 1 by 12.783 cube root, right? Let's take the cube root. 3 is equal to 1 by 2.34. Okay. So 1 divided by 2.34 is equal to 0.428. Okay. So now what we have to do, 1 by 1 plus 0.428. This is equal to 1 by 0.428. 1 divided by 1.428. This is equal to 0.700. Yes. Manas and Yamuna, both of you are absolutely right. Okay. So that is Dombey's class. And I'll leave this question up to you guys. Okay. You can do it later. It's the same. So again, you have to take two pairs, 0.2, 0.4 here, 0.7, 0.7, 0.8, 0.3. You'll get three membership values for all the three values of X. Okay. So this is for S norm. So please try yourself. Okay. Now we'll look at Du Bois-Brady's class. Okay, so in the last one, we were multiplying both the membership values and then we have divided by and we have taken the maximum of nu A, nu B and alpha. So here what we are doing is we are going to add nu A. I'll share the notes on NPTEL so you can take it. Yeah, but in case if you just want to write it down, note it down now. I'll wait for a minute. Okay, done. So previously we have taken the multiplication between the two membership values. So now what we are going to do is we are going to add both nu A and nu B, right? And then subtract nu A cross nu B, the multiplication value, and also subtract the minimum value among nu A, nu B, and 1 minus alpha. Okay. So kind of remember the differences between both so that you will remember both the equations without being confused. Okay, so that is for the numerator part. In the denominator part, in T norm, parameterized T norm, we have taken the maximum value of nu A, nu B and alpha. Here we are going to take the opposite. We are going to take the complement values. 1 minus nu A, 1 minus nu B, and alpha is not the membership value, right? It's a parameter. So we are leaving the parameter as it is. Okay. So this is for S norm or parameterized S norm. Okay. So I suggest you to try this one out yourself. Okay. So please note down the question. For the interest of time, we'll go to the other parts. Okay. But in case if we finish the class early, then we'll come back to these and we will solve it together again. Okay. I'll wait for a minute so that you can copy the questions and the function. Let me know once you're done. Okay. Thank you, Yamuna. Manas, you're done. Thank you so much, guys. So try yourself. But in case if we still have time before it like before it's 8 o'clock, then definitely we'll come back and we'll try it out together. Okay. Okay. And the last class in parameterized S norm is Jager's class, right? So in this, we are going to take the minimum of in between 1 and nu a of x whole power omega plus nu b of x whole power omega and whole of 1 by omega. Okay, and the omega values lie in between 0 to infinity, and please note that it does not include 0. Okay, it only includes the values which lie in between, which are greater than 0. Okay, uh, so this is another question for Jager's. It is again simple. You take each membership value from both the fuzzy sets, and then you put it in the function and you put the omega value and then you get it. Okay, so we tried. So, okay. Thank you, Manu. Oh, okay. You guys are it's an old message. Okay, please note down the question and let me know once you're done. Thank you, Yamuna. Thank you, Manas. Okay. So now we are going to the other next part. We call it as fuzzy relations. Okay. So when two fuzzy sets are given and you are asked which one like is greater for a given value of x, you have to come up with some answer, right? So if I'm saying there are two fuzzy sets at x, okay, let us say these two are two fuzzy sets, okay. So this one has a membership value of 0.3 and this one has 0.7 for the same values of x. Okay, let us call this as A and this as B. So there'll be some conditions where I want all the values where B is greater than A. All the x values where the membership function of B is greater than A, right? If it is 1 or 2 or 3, you can directly like check and write it down. But when it is multiple pairs are happening, okay, multiple possible pairs are happening, then it will be difficult for you to find which one is higher and which one is not higher. I mean, which one is lesser. Okay, for these comparisons and all such things, we use the fuzzy relation. Okay, so in this, we take for two given fuzzy sets A and B, we have the Cartesian product A cross B. Okay, So for example, if we have A is equal to 0, comma 1 and B is equal to ABC. Okay. So if you notice here, for A, 0, comma 1 is only given. So membership values are not given, right? So it is a crisp set. So for B, A, B, C are given, right? So now when we take a Cartesian product between both the crisp sets A and B, multiple pairs, there's a possibility of multiple pairs, right? 0, 0 A, 0 B, 0 C, right? For one element in A, there are three mappings. And again, for another element in A, another three mappings. So total we got six pairs, right? 0A, 0B, 0C, 1A, 1B, 1C. Okay, that is for A cross B. If I'm taking B cross A, we have to map from B towards A. So the first element in the pair is going to be from B, and the second element in the pair is going to be from A for B cross A, right? So we'll go this way: A to 0, A to 1, A to 0, A 1, B 0, B 1, C 0, C 1. Okay. So this A cross B and B cross A, these all are called as Cartesian products. Okay. So you might be asked question in such a way that find relation Q of AB, that is first element is greater than the second element in A cross B. So now we have A, now we have B. Okay, first we'll try to write down all the pairs together. Yeah. So this is for A cross B. 1, 1 to 2, 1, comma 2, 1, comma 3, 1, comma 4, 2, comma 2, 2, comma 3, 2, comma 4, 3, comma 2, 3, comma 3, 3, comma 4. Then 4, comma 2, 4, comma 3, and 4, comma 4. Done, right? Okay. How many did we get? 3, 4, 5, 9, 10, 11, 12. So here we have 4 elements. Here we have 3 elements. Right? 4 plus 3, 12. So now we have got total 12 pairs. Right? So far clear? Okay. So we have got our A cross B pairs. Okay, these are just pairs. So the first question is, list out all the pairs that has the first element to be greater than the second element. Okay. So let us identify what all are there. First element greater than second element. Not here, not here. Yes, this is there. This is there. And okay, this is not there. Right? We have 2. We have 4, comma 2 and 4, comma 3. Right? Only for these two pairs, the first element is greater than the second element. Then let us look at another one. First element is less than the second element. So this, 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 this. We have one more in the previous one, 3, comma 2. The first element is greater than the second element. Sorry, I did not notice that. Okay. And then for first less than second and this. Right? For all the pairs are 1, comma 2, 1, comma 3, 1, comma 4, 2, comma 3, 2, comma 4, and 3, comma 4. For the first and the second elements to be equal, the values are 2, comma 2, 3, comma 3, and 4, comma 4. Right? So far clear? Okay. So, as I told here, Q is nothing but a relation, right? So let us call this as Q1, Q2, and Q3, right? Because we are just finding the relations between both elements in between the pairs, right? So now we'll see something called as a relational matrix. Take it from okay. So in this, uh, let us just write all the elements on both the axes. Okay. So for A, 1, 2, 3, 4. For B, 2, 3, and 4. Okay. So for a given relation, so now we had only like 12 pairs. So we immediately like wrote it down easily, right? So let us take the first relation. Okay. When we have multiple elements, finding the pairs, writing it down, and then comparing each and everything will take a lot of time. So instead of doing all of that, we'll shift to some this relational matrix. Okay, let us draw lines. Hmm. So Q1, what is Q1? First being greater than second. Okay, the first is A, the second is B. So just see here itself. 1 greater than 2, no. 1 greater than 3, 4, nothing, right? So these all will become 0. Then check for 2. 2 greater than 2, no. Anything greater than the rest of the values? No. So it's all 0. Then let's look at 3. 3 greater than 2? Yes. So let's put 1. 3 greater than 3? 0. They both are equal. And this is 0. 4 greater than 2? Yes. Yes. And yes. So the relational matrix for Q1, that is for first greater than second, is going to be this. So if I say Q2, that is first less than second, wherever 0 values were there in the previous part, except this, this should also be 0, sorry, and this. Uh, yes, Yamuna, sorry, it was a mistake. Sorry. Yeah. So except these three, the other all will become 1 and not even these. These also will become 0. Okay, that is Q2. For Q3, this, and this will only become 1 and rest all will be equal to 0. Right? So that is a relation matrix. Understood? What I was trying to write here. So far clear? Any questions? Okay. Now we'll see another one. Okay. So now we have two fuzzy sets A and B. Now we want to find the Cartesian product. Okay, so how are we going to do that? Is a question. Okay, so previously we were looking at a crisp set. Okay, where the membership values are not there. So in the absence of membership values, so that is going to be a normal set with the membership value equal to 1. Okay, like the membership value does not exist for a crisp set. So it's basically it is going to exist in the set. So whereas when we take fuzzy set, it is existing with some sort of a probability, right? So For a crisp set, we have used this relational matrix and we have identified which element is greater, less, and all of that for a given set of pairs. So now we also have to deal with membership function. So how do we deal? First step in finding a Cartesian product in for a fuzzy set is first you identify the pairs. Write down all the pairs similar to what you have done in the last case, right? And then for the membership value for the given pair, it is going to be the minimum value of new A comma new B. Whichever is minimum, that is going to be your membership value. Okay, let us see. So here the pairs x1 comma y1. This is A cross B. Okay, x1 comma y2, x2 comma y1, x2 comma y2, x3 comma y1, x3 comma y2. Right? We have 6 pairs in total. Okay. Now, for the first pair, x1, y1, the membership value is going to be minimum of whatever is there with x1, 0.2, and whatever is there with y1, that is 0.3. So that is equal to 0.2. Right? And then for x1, comma y2, minimum of 0.2, comma 0.9, that's going to be 0.2. So like that, you find for everything. And at the end, you write the fuzzy set as x1, comma y1, comma 0.2. So this is one element. And then x1, comma y2, comma 0.2. This is for the second part. Like that, you do for all the pairs. You do it for all the 6 pairs. Okay, and that is going to be your new fuzzy set. Clear so far? Okay. So for this one also, you can make a matrix. Okay. Let us find the matrix B. This is A. A has x1, y, x2, x3. Here you have y1, y2. So in the previous one, we were looking at the relation and then we were writing it as 0 and 1. We were just using the binary form. But here, what we do is when we take x1, y1, we check the values. So which one ever is minimum? For x1, y1, the minimum is 0.2. So here it is 0.2. Then take x1, y2. x1, y2, minimum is 0.2. So write 0.2 here. x2, y1. x2 is 0.5, y1 is 0.3, minimum is 0.3. x2, y2, 0.5, 0.9. So it is 0.5. x3, y1. x3 is 1 and y1 is 0.3. So this is 0.3 and 1 and 0.9. So it is 0.9. So this is how you use a relational matrix. Okay. Some real world examples were also given in the class, I think, using some cities or something. I exactly don't remember. Okay, so during the class, one another example, like instead of using x1, y1, x2, y2, and all of these things, uh, uh, sir has used some cities as names. Okay, and then reach. I think the matrix was approachability or reachability. So basically, going from one place to another place So how easy it is to go. Okay, so that was something like that. And like basically going from some Indian cities, for example, Mumbai, Kanpur, and Ahmedabad, I guess, I'm not sure. So from one place, going to a different place, like Malaysia or London or Hong Kong. Okay. So how easy it is to go from this place to this place? Like what is the connectivity? Connectivity flights, are they good enough or are they not good enough? So for example, if you look at this matrix here, okay. So when you are taking x1 and y1 together, the values are low, 0.2. But when you're taking x3 and y2, the membership value is high, right? So there is, how do you see? There is a more probability of x3 and y2 happening together than any other things happening together. Okay. So if I'm saying x3 is one city and y2 is another city, the connection, flight connections in between x3 and y2 are frequent, I can say. Okay. And that is the reason it is having a higher membership value. But if I'm taking any other place, x1 and y1, the membership value is low, which means if we are considering x1 and y1 as two different cities, then the connectivity is low. Like it is just an example. It can be any other parameters that you're taking. Maybe you're comparing two metal properties together. Okay. Let us say you want to use two metals two metals and merge them, but not sure which metals to merge together to attain some sort of a property. Okay. So how do you do it? Then you use this relational matrix. Okay. So that is all about fuzzy relations. So how do you use some operators for these fuzzy relations? Okay. The first one is union. For a given crisp set, if we are saying union, you take this. If this is R, this is S. If I want to take the union, I take all the values which lie in between this and this, right? So that is something that we already know. But when it comes to these pairs, right? So I hope you all remember when we have two fuzzy sets and we are trying to find the union between both of them, then we take the maximum membership values in between A and B, right? So similarly, but instead of having just X or X value here, here we are having a pair, X comma Y. Okay, you have your X comma Y, the pair, and then the corresponding membership value. So this membership value is nothing but membership value of R union S. And union is nothing but taking the maximum membership value in between R and S. Okay, so whichever one is maximum, that is going to be your new T. That is union. And I hope you, by now, you would have already guessed how you will do for intersection. So for intersection, you take the minimum membership values in between R and S, right? So for a crisp set, you take the common ones, whereas in a fuzzy set, you take the minimum membership value, whichever is the minimum. And then instead of just having X value, you have a pair, X comma Y. So that is intersection. And then we have complement, right? So complement, as usual, what we have done earlier, when we if we are having a membership value new, and if we want to get the complement of new, it is going to be 1 minus new, right? Similarly here, first you'll write the pair followed by new r bar. So new r bar here is nothing but 1 minus new r. Is it okay if we take a quick 10 minutes break? Okay. I kept talking and now my throat is kind of irritating me. Can we just take a 10-minute break? I'll just drink some water and come back. Thank you so much. Just a 10-minute break. I'll discuss the next functions. Okay. Hi, thanks a lot for waiting. Okay, shall we continue? Okay, so far we have seen union, we have seen intersection, and we have seen complement, right? Now we will see containment. Containment means so one fuzzy set lying in another fuzzy set, right? Or if we are taking a crisp set, let us say this is okay. This is R, uh, this is S, okay? And we want to know if R belongs to S. So R should lie inside S. Then we say R is contained in S. So similarly, this also. So for the pairs also. So when we do, so instead of containment, what we do is when we take the membership values of new S should be greater than new R, or R should be less than S. Okay. So these are all the operations that we have. But now you might have a question. So when are we going to take X? When are we going to take X comma Y? Let us do a simple example. Okay, let us say we have two metals, metal A and metal B. Okay, and we are trying to see different properties of metals together. Okay, of both A and B. Like we are trying to combine both of them together, and we want to check two things. Okay, one is the strength. Okay, any other thing? Any other metal properties? Let us take temperature resistance. Okay, so now let us say these are the two things that we want to find when we combine both of them together. Okay, so let us draw. This is for metal A. This is for metal B. Okay, so this is for strength. In order to calculate strength, let us say we are taking different characteristics of both A and B together. Let us just call them as x1, x2, x3, y1, y2, y3, right? And here we'll have some values, right? 0 0.2, 0 0.1, 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9, 1.0. These are all random values that I have generated. Okay, so x1, x2, x3, and y1, y2, y3. Let us just call them as different material properties in order to find the strength of the materials A and B. Okay, when we combine them. Okay, so similarly, we have B and A to get the temperature resistance. Okay, to get the temperature resistance. Again, we have different parameters. We are taking different properties of metal A and metal B. And I'll call this as okay, B1, B2, B3, A1, A2, A3. Okay. And again, I have different values. Okay. Again, I had different values. This is for temperature resistance. I want to know what like what okay, let us say these are all our compositions. Okay. Maybe 10% of B, 20% of B, 30% of B, 10% of A, 20% of A, 30% of A. Like that. Okay. So now I want to uh like combine metal A and B together such a way that I get maximum strength and maximum temperature resistance. Okay. So I take both the values together, and then I form this pairs. Okay, another one, A and B. Okay, and all the things, all the operations that we were doing so far, right? We, depending on the problem, we do some sort of operation, and then we get again all the values. Okay, so this is based on pairs, all the pairs that we were doing till now. Okay, x comma y. Uh, is it clear? Or so let us say we are taking the intersection of strength and temperature resistance. Okay, that means that you are going to take the uh, smallest minimum membership value, right? So for this one 0 0.2, 0 0.1. So 0 0.1, then again 0 0.1, 0 0.3, 0 0.5, 0 0.4, 0 0.6. I'm taking these values here. Okay, 0 0.8 and 0 0.7, 0 0.7, 0 0.9, 0 0.8, 0 0.8, 1 and 0.5, 0 0.5. Right? So like this, we'll take the intersection. So if I want both strength and temperature resistance in the fusion of both the metals, metal A and metal B, then this is what I'll do. So first I'll take the strength matrix, and then I take the temperature resistance matrix. And then I want a combination of both of them together. And that is when the pairs will form. Clear why we are doing all of these things and questions like that? Thank you, Manas. Yamuna, clear? Okay. Oh, you're here. Hi, Amber. Yes. Okay. Great. Thank you, guys. So, uh, that is all the theory part so far. Okay. So, we'll just discuss previous years or previous time when this course was offered, those assignment questions. So, okay, take a wild guess and try the answer. What is a parameterized T norm, also known as? Yes. Yamuna and Amber, you both are right. The answer is B. So norms, T norm is also called as S conorm, and S norm is also called as T conorm. So in Domby's class of T norm, the range of the parameter lambda is. Yes, Yamuna, you are absolutely right. The answer is D. So for Domby's class, we take the values 0 to infinity. Yes, Manas, you're right. Okay. What is the range of the parameter alpha in Du Bois-Prade's class of T norm? C. Yes, yes, Manas and Yamuna, you are right. The answer is C. The alpha values lies in between 0 and 1. Okay. In Jaeger's class of T norm, how does increasing the parameter W affect the resultant fuzzy set obtained from the intersection of two fuzzy sets? So this part was actually taught in the class. Okay. So for different values of lambda, uh, okay. So for the same membership values, for the same values of x, the lambda values were varied. Okay, as they were kept increasing, and you will find a difference in the first and the third type of classes, but in the second class, you don't find that a difference. Okay. So the answer is C. Oh, sorry. Jager's is W, but I I just had the first one in mind as lambda. Okay. So it increases the membership values when we increase the value W. Okay. So if you're interested to know how this answer is given, so go back to the questions that we have solved in the beginning of the class in Jager's, and try to change the values from we have taken W is equal to 2. So change it to W equal to 3 and W equal to 1 and try to get your values. Okay. Okay. Next question. How does increasing the parameter alpha affect the resulting fuzzy set in Du Bois-Brady's class of S norm? Okay. For now, I'll just tell. So for Du Bois-Brady's, when we increase a parameter or decrease a parameter, the membership values does not change. Okay. But whereas for the other two, for the Jager's and the other one, sorry, I forgot the name. So for them, the membership value definitely changes. But for Du Bois-Brady's class, it does not change. Okay, it's not change. Okay. Next question. What parameter determines the behavior of the resulting fuzzy set in Du Bois-Brady's class of S norm? The answer is already there at the previous question. Answers? Anybody? Yeah. Yes, Yamuna, you're right. So, yes, Amber, the answer is A. So, for Du Bois Pratis, we take alpha. What is the Cartesian product of two arbitrary crisp sets with universe of discords X and Y? Yes, Amber, Yamuna, you are right. The answer is C. Okay, the Cartesian product means we take the A cross B or B cross A depending on whatever is asked. Okay. In a Cartesian product of two crisp sets A and B, how many ordered pairs are obtained if the set A has 4 elements and set B has 3 elements? I think our question also had one of the example questions that we were seeing also had the same number of elements. Yes, Amber, Manas, and Yamuna. So that's right. The answer is D. That is 12. So 4 elements, 3 elements, 4 cross 3. 12 pairs will get in total. How is approachability between elements of different sets represented in okay, I think I didn't tell this one. So the approachability here is nothing but this whatever we have done here. Okay. So when two different sets are there, and how do we find the approachability? Like what exactly are we using? Are we using a Boolean logic or a crisps relation or membership degrees? Yes, yes, Yamuna, Amber, you both are right. We use a membership degree. We use the membership degrees. So from both the sets, we are taking the minimum or the maximum, whichever operator we are going to keep there. Based on that, we are using the membership values only, right? So using the membership degrees. So the last question: what operation is performed when finding the union of two crisp relation sets? So what is it for a union? For a union, yes, Manas, you're right. So for a union, we take the maximum of the membership values, right? Okay. So with that, we are done with last year's questions. So we have left a couple of questions in the beginning, right? Do you want to try it yourself, or do you want me to like do it? We still have 17 minutes, so it's fine. Uh, whichever ones you prefer, we will try. Okay, Amuna. Amazing spirit. Okay. But in case if you are not able to like get the values or else, okay, just drop a message in the Google groups. Okay. With respect to the problem solving sessions, I'll answer, but rest of the things the other TA will answer. Okay. Also, again, as said in the beginning of the class, so in case if you have questions which are outside the syllabus, which is covered in the class in the actual NPTEL class, uh, kindly drop a message in the Google groups because I don't want to give a wrong answer. Okay, so it's better if you drop the message in the Google groups, and the TA who is closer to the professor there will directly go to him and talk with him and reply to you or answer your questions. Okay. So, but with respect to today's class, do you have any questions with respect to today's class? No. Okay. Uh, some of the questions in assignment were not taught by sir. Just give me 1 second. I'll just check. In previous assignment, you mean week four, week five, Manas? Second, it's just taking a lot of time to process for some reason. Week six also. Okay. I'll just stop sharing here. I'll open the 1 second. Week four, question three. Okay. It is Week 4, question 3, the distance metrics. That one? No, but we had discussed about distances, uh, but we did not give the names and all of that for that. Yeah. Hamming and Euclidean. Okay. Uh, for question 6, sorry, assignment 6, which question number? Oh, markers. Uh, can you all just drop that message in the Google discussions? Yes, yes, it's not given in the discussions even. I noticed. Okay. Uh, I'll also raise the question. Like I'll also send a mail to NPTL people from my side. Okay, but eventually they will reach out to professor and they'll make the changes. Okay. Okay. From my side, I'll raise a. I'll send an email to NPTL today itself. Okay. For both week 4 and week 4 question 3 and week 6 question 6. But both of you also please do send, like, write it on the Google groups. It be replaced with most probably everyone might get a bonus point. That, like, that's usually how it happens. Okay. They don't replace the question, at least for the older assignment. But for the new assignment, they might change, but by the time they process it and all of that happens, usually the deadline passes. So once the deadline passes, they can't change the questions in the last minute, right? So it's highly likely that everyone will be awarded marks for that question. But if they do change before the deadline, then yeah, most definitely there is a possibility of that also happening. Okay. But okay, I'll send an email regarding both of these questions, week 4 question 3 and week 6 question 6. Okay. Any other issues with the assignments? Please try as many students are. Yes, yes. It will not be taken lightly. People will take it seriously. Okay. I'll send an email. You don't have to worry regarding that. Okay. Any other questions in today's class? Okay. Thank you so much, everyone, so for joining today's class, and you guys have been really really active today, and absolutely I loved it. Yes, Amber, ask your question. In Jager's S now, if we increase W, will membership value decrease? Go to Jager's. Just a second, I'll share. Okay. Let us take W. Give me 1 second. I'm sharing my screen. Okay. So this is one of the examples that we had solved earlier. Okay. For this one, I believe we took, okay, W equal to 2. Okay. Uh, Let us decrease the W and see how this one changes. Just remind me that I have to do this. So let us just take for one value, 0.3 and 0.5. We have 0.3, 0.5, mu A and mu B. This is for x equal to 1. Okay, let us take W is equal to 1. Okay, for easier calculations only, I'm just taking this. So TW is equal to 1 minus minimum of 1 comma 1 minus mu A W plus 1 minus mu B W whole 1 by W, right? 1 minus minimum of 1 comma 1 minus mu A, that is 0.1 minus 0.3 power 1, that is 0.7 plus 1 minus 0.5, 0.5 whole power 1. 1 minus minimum of 1 comma, this is 1.2. So this is equal to 0, right? So for x equal to 1, at W equal to 1, we got the value to be 0. At x equal to 1, for W equal to 2, we got the value 0.14. So is it increasing or decreasing as we increase the W value? Increasing. Hmm? So that's it. So it is going to increase. Okay. Any other question? Is it given in the lecture opposite? Like, was it opposite in the? Just check. This is for T norm only. Oh, sorry. This is for S norm. I did it for T norm. This is T norm. Let us go to S norm and try that question then. Okay. Uh, we'll try for S norm for W equal to 2. Minimum of 1 comma mu A is 0.3 whole square plus 0.5 whole square root 1 comma this is 0.09 plus 0.25 0.09 plus 0.25 square root of 0.09 plus 0.25. So this is equal to 1 comma 0.583. We need the minimum. The minimum value is 0.583. Right? Okay. So this is S2. If we are taking S1, then it is minimum of 1 comma 0.3 plus 0.5 is equal to minimum of 1 comma 0.8, that is equal to 0.8. Oh yeah, okay. So when W is equal to 1, W equal to 1, we had 0.8. When W is increased, then the value decreased to 0.583, right? So what was given in the lecture verified? Amber? Okay. So before I have done it for T norm, so that is the reason it got increased. But for S norm, it is opposite. It is decreasing. Okay. 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 With this, we'll end today's session. Okay. Okay. Thanks a lot for joining. Have an amazing weekend. In case if you guys are around Bangalore, tomorrow there is open day at IISc. So the entire institute will be open for anybody to come and see all the experiments and all the cool stuff which happens in the institute. Okay, so in case if anyone is around Bangalore, to definitely come to IISc. Okay, so yeah, with that, I'll end today's session. Thanks a lot for joining and have an amazing weekend. Bye, guys.